We have example number 2, x minus a raised to 2 plus y squared equals a squared, and then eliminate the constant a. So for this problem, we only have one constant, which is a. Therefore, if that is only one constant, then we only have to take first derivative because we only have one constant. We will not reach to second derivative. Okay, so this one is in implicit form. So we will take the first derivative of our implicit form. So take the derivative of this part with respect to x. So you have 2x minus a, 2 minus 1, that is 1, plus the derivative of y squared equals 2y y prime, which is equivalent to the derivative of a squared, where a is constant, so this is equivalent to 0. And then you have to multiply 2, distribute 2, so 2 times x, that is 2x, minus 2 times a, that is 2a, plus 2y y prime is equivalent to 0. So for this case, we have 2a, I will transfer 2a to the other side, that becomes 2x plus 2y, y prime is equivalent to 2a. If you have noticed, they are all divisible by 2. So if we divide both sides by 2, what remains here is x plus y prime is equivalent to a. So this is our a equals x plus y prime. Initially, our problem, we will call this one as our equation 1. This time, after we take the first derivative, we will call this one as our equation 2. So we will combine equation 1 and 2. Okay, so combining equation 1 and 2, equation 1 and 2, equation 2. So when we combine equation 1 and 2 and substitute the value of a as x plus y, so going back to this equation 1, we have our x minus a, okay, x minus a. But instead of a, writing a, I will substitute the value of a from the equation 2. Okay, I am combining equation 1 and 2. So substitute the value of a as x plus y prime, so squared. X minus the value of a is x plus y prime, so we have this one, plus y squared, that is equivalent to, instead of writing a squared, I will write this one. So instead of writing a, I will write x plus y prime square. Okay, so when we combine this one, x minus x, that is equivalent to 0. So what remains here is y prime, and then we have here raised to 2. So I will write here y squared and then y prime squared. Okay, distribute your power, y squared and then y prime squared, plus y squared, we have this one y squared. Okay, or instead of writing this one, I will write here as y prime squared. Okay, this one, y prime raised to 2. Okay, y squared equals, okay, we will expand this one raised to 2. So x times x, that is x squared, plus 2 times x equals 2x times y prime. And then squaring this one, you will have plus y prime square. So if you have noticed, you have the same y prime square on both sides. So we will cancel this one, both sides. So what remains here is y squared is equivalent to x squared plus 2x y prime. Equating this one to 0, okay, when we equate this one to 0, of course, we will just transfer this one to the other side. That becomes y squared minus x squared minus 2xy y prime is equivalent to 0. So that will be our value. Or instead of writing y prime, we have our dy over dx. Okay, so this is just an alternative answer. Okay, y squared, or okay, we're gonna write our final answer as y squared minus x squared minus 2xy. Instead of writing y prime, we have dy over dx equals 0. And then this dx multiplied to this part, that becomes y squared minus x squared dx minus 2xy dy is equivalent to 0. So we can have this one as our final answer, or we can have this one as our final answer. So it's up to you for your final answer. Okay, so that is our example 2 for eliminating the arbitrary constant. For this example, we combine equation 1 and equation 2, and for its combination, we use substitution method. We substitute the value of a as x plus y prime. We have this one. Instead of writing x minus a, we have x minus x plus y prime. In our second example, in our first example, we do the elimination, elimination method. This one is we use substitution method for when we combine the two equations. Okay,